Hello GATE aspirants. Welcome to part 6 of GATE Classical Mechanics series. Question number 11. A satellite is moving in a circular orbit around the Earth. If T, V and E are its average kinetic, average potential and total energies respectively, then which one of the following options is correct? Now we know from virial theorem T, that is kinetic energy, average kinetic energy is n plus 1 by 2 V, where V is proportional to R raised to n plus 1. The satellite is moving in a circular orbit, so potential is of this star minus Gm by R. It is inversely proportional to R, so V is proportional to R raised to minus 1. That means minus 1 is equal to n plus 1. That gives us n is equal to minus 2. So T is equal to minus 2 plus 1 by 2 V. That is equal to minus 1 by 2 V. So V is equal to minus of 2T. Now total energy is equal to T plus V, which is T minus 2T, which is minus T. So E is equal to minus T and V is equal to minus 2T. So here option A is correct. Next question. In an inertial frame S, two events A and B takes place at CTA is equal to 0, RA is equal to 0 and CTB is equal to 0, RB is equal to 2y respectively. The times at which these events takes place in frame S dash moving with velocity 0.6 c y cap with respect to S is given by. So frame is moving in y direction. Now TA dash will be equal to TA minus V by C square, and it is in y direction, so y upon under root 1 minus V square by C square. Now for A, we have TA is equal to 0. So TA is equal to 0 and y is also equal to 0. So this will be 0. So we have two different events. So for two different events we have to write this. Okay. So we have, let us take event by event. So for A, we have TA is equal to 0 and we have y is equal to 0. So TA dash will be equal to 0, because here if we put TA and y 0, we will get 0. Similarly, TB dash, this will be equal to TB minus V by C square y upon under root 1 minus V square by C square. Now for B, we have TB is equal to 0 and y is equal to, it is given y is 2. So TB dash will be, here we have 0, so 0 minus 0.6c upon C square into 2 upon 1 minus 0.6 square, which is 0.36. So minus 1.2 by C upon, this is 0.64, square root is 0.8. So this is minus 1.2, 0.8c, which is TB dash is equal to, this is 3 by 2. So minus 3 by 2. So CTB dash is minus 3 by 2. So option A is correct. CTA dash is 0 and CTB dash is minus 3 by 2. Next question. Consider the motion of the sun with respect to the rotation of Earth about its axis. If Fc and Fco denotes the centrifugal force and Coriolis force respectively acting on the sun, then. Now centrifugal force is always radially outwards. So this, it will be radially outward. So this option is wrong. And Coriolis force is minus twice m omega cross V, and omega cross V is m omega cross V is centrifugal force. So this is minus 2 centrifugal force. So option C is correct. Next question. The Lagrangian of a particle of mass m at a position r bar moving with velocity v bar is given by this, where v of r is potential, c is a constant. If pc is the canonical momentum, then its Hamiltonian is given by L is given. Now Hamiltonian H is equal to r dot p minus L, where p is dou L by dou r dot. So here we have this Lagrangian L is equal to half m v square is r dot square plus c r dot minus v of r. So dou L by dou r dot is equal to m r dot plus cr. So from here r dot is equal to p minus cr upon m. So h is equal to p minus cr upon m into p minus L. L is half m. Again r dot is p minus cr by m square minus cr, p minus cr by m, and minus 1 is equal plus, so v of r. So this is h. So h is equal to p minus cr square by m, and here we have 2 so this will be by m minus half into p minus cr square by m plus v of r. So this will be equal to p minus cr square by m plus v of r. Here I am taking this p minus cr common, so you will have p minus cr by m again. So after simplifying you will get this, and this is equal to option number B. Question number 52. The Hamiltonian for a system of two particles of masses m1 and m2 at r1 and r2 having velocities v1 and v2 is given by h is equal to, where c is a constant, which one of the following statements is correct? First is the total energy and total momentum are conserved. Now here, as we can see, h is not a function of time. So if h is not a function of time, then energy is conserved. That means energy is conserved. Next, this potential is in only z cap direction. So h is equal to Th is equal to kinetic energy plus potential energy, and this first part is kinetic energy. The second part is potential energy, and potential energy is only in z direction. That means this potential V is symmetric about z, about that phi axis, is symmetric about phi. That means this Lz is conserved. So h is not function of time, so energy is conserved, and potential is only in z direction, hence it is symmetric about phi, so Lz is conserved. So that means the total energy and the z component of total angular momentum are conserved. So option C is correct here. Next question. A particle of mass 0.01 kg falls freely in the Earth's gravitational field with an initial velocity v0 is equal to 10. If the air exerts a frictional force of the form F is equal to minus kV, then for k is equal to 0.05 Newton per meter second, the velocity at time t t is equal to 0.2 seconds. Now equation will be ma is equal to, it is falling due to gravity and it has frictional force, that is kb. So this can be written as, let us divide by m throughout, and a is dv by dt is equal to g minus k by m into b. So dv upon k by g minus k by m, g minus k by m into v is equal to dt. Let us take integration on both sides. So this will be equal to ln of g minus k by m v upon minus k by m is equal to t. Now initial velocity is 10 and final velocity is some value v. Let us take u here because final velocity is some u, and initial time is 0 and finally it is 0.2. So this will give us ln of g minus ku by m minus ln of, here we will put initial value which is 10. So that is g minus k 10 by m is equal to this minus k by m here into 0.2 minus 0, which is 0.2. So let us substitute all the values. So ln of 10 minus k is 0.05 u upon mass is 0.01 minus ln of g is 10 minus 0.05 into 10 upon 0.01 is equal to minus 0.05 upon 0.01 into 0.2. So this is ln of 10 minus 5u minus ln 10 minus this is 50. So 10 minus 50 is minus 40 is equal to minus 1. So this is ln of 10 minus 5u upon minus 40 is equal to minus 1. So this will give us, if we write it like this, then to remove this logarithm we can write 10 minus 5u upon minus 40 e raised to minus 1. I'll just take antilog on both sides. So we will get, and take minus sign here. So this will be equal to 5u minus 10 upon 40. It will be equal to 1 by e. So u is equal to 40 by e plus 10 upon 5, and that comes out to be 4.94. So answer is 4.94. Answer given in the answer key is 4.93 to 4.98. Next question. A particle with rest mass m is at rest and decays into two particles of equal rest masses 3 by 10 m, which move along the z-axis. Their velocity is r. So initially it is at rest. So finally also total momentum will be 0. So that is P1 plus P2. So mod P1 is equal to mod P2. And energy will also be conserved. So initial energy is E1 plus E2. Now initial energy is mc square. And these two masses are of equal mass. So that is 3 by 10, 3 by 10. So that will be equal to 3 by 10 m into c square upon 1 minus v square by c square. This will be mass of one particle, so into 2. So this mc square will cancel and you will get under root 1 minus v square by c square is equal to 3 into 2 is 6 by 10, which is 3 by 5. So 1 minus v square by c square is 9 by 25. So v square by c square is 16 by 25. So v by c is equal to 4 by 5 into c. So v is equal to 4 by 5 into c, which is equal to 0.8 c. So option B is correct. Both will be having velocities in exactly opposite direction, same magnitude, and it is 0.8 c z cap. So these were all the questions from classical mechanics part from GATE 2015 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.